Okay, so like we just saw in our in that titration there. No, we're not going to do that. We're not going to write the net ionic equation for that. Okay, so let's look at this scenario. This is on the bottom of page 6. This is the bottom of page 6 in your notes package. Yeah, it's in the bin. Does this kind of look like exactly what we just saw? Yes, it does, okay? So what we did is we titrated sodium carbonate with HCl. That's exactly what we just did on the with our titration. Now let's take a look at this. About halfway, right? If I went halfway between here and here, seems like that's the equivalence point. What's the pH of the first equivalence point?
8.
It's a little, the way I drew it, okay, which might be a little bit different from the way you drew it. It was just like a tiny, I kept going up, but it should be a tiny, tiny, tiny bit above 8, okay? Do you want to call it 8.1? Is that okay?
8.2.
8.1, we're going to call it 8.1. So what indicator could you use to differentiate between an equivalence of 8.1? What kind of an indicator would be appropriate? Okay, let's go from top to bottom. Would methyl violet be okay? No. Would cresol red be okay? Yes. Yes. The first, remember, the cresol red has 2 different color changes. So the first color change, no, but the second color change, yeah, okay. All right. What about thymol blue? Would that be okay?
Yes.
8.1's pretty close to the beginning of that one, okay? So I would be wary of it, but, whatever. We can maybe accept it. Orange wort, would that be okay? No. Stop me when I get to the next one, that's okay. No. Well, looks like there was only kind of 1 or 2 options, right? Looks like cresol red's the only option that's going to work for us. So we would use, the indicator would be cresol red. Can I get you to tell me which indicator you want to use for the second equivalence point, right? This is the first equivalence point, that's the second equivalence point. Did you guys get a pH of like 4.3 or something like that? 4.2, 4.3? Okay. So what did you get, Lynn? Bromo cresol green. That seems pretty good. 4.3 is like right smack dab in the middle of that, right? Is there anything else that we could use?
One below it.
The one below it? 4.3 is outside of this range, right? 4.3 is too low. 4.3 is getting pretty high for this, right? So bromo cresol green is probably the only one that I would choose, if that's okay with you. All right. So since this is a pH of 4.3, then that means bromo cresol green. Is anybody confused by how we pick indicators?
No.
Does that seem fairly straightforward? Yeah, the way I would always do this is I would actually legitimately draw the 2 lines right? And halfway between those two lines is your equivalence point. Figure out the pH and then move on. Okay, write the net ionic equation for a 1-to-1 reaction of sodium carbonate with hydrochloric acid. Let's do this. What that means is we're going to react 1 sodium carbonate with 1 hydrochloric acid. 1 sodium carbonate with 1 hydrochloric acid. Okay. This is a little bit rough. We're not reacting 2 of these, or sorry, 1 of these with 2 of these. It's just a 1-to-1 ratio. So carbonate is a base. It will steal the hydrogen. Does that make sense? Bases steal hydrogens. So basically, what's going to happen is the sodium and the hydrogen, one of them are going to swap places. Is that okay? 1 sodium and 1 hydrogen are going to swap places because we're only adding enough hydrochloric acid to react this one time, okay? So sodium and hydrogen are just going to swap places. So we get sodium hydrogen carbonate Is that okay? 1 sodium, one of them swapped with the hydrogen. Is that? Just roll with it. And then we've got, what else? If the hydrogen's gone, what did it trade with? A sodium chloride, right? Okay. Okay, so now split up everything that can be split up. Can sodium carbonate split up? Why? It's an aqueous ionic compound, right? So we're going to get 2 sodiums. This is going to be a big one, by the way. This is going to be a really long one. Plus carbonate. Can hydrochloric acid split up? Can acids sometimes split up? If they're strong acids, right? Is hydrochloric acid a strong acid? Yes. Can sodium hydrogen carbonate split up? Is it an ionic compound? Is it an aqueous ionic compound? Yes. Then it will split up. And ionic compounds only split up into the 2 ions that make it up. What are the 2 ions here? Sodium and whatever's left, right? What's left? HCO3. That's hydrogen carbonate. So we're going to get sodium. Hydrogen carbonate won't split up. Why? Because it's a polyatomic ion, right? But also, hydrogen carbonate is a weak acid / weak base. And so remember, weak acids and weak bases don't split up. Okay? And then finally, sodium chloride. Is sodium chloride going to split up? Yeah. So we're going to get sodium and chloride. Let's try and cancel out as much junk as we possibly can. Can these 2 sodiums cancel?
No, because it changes. Maybe. Because you get 1.
Can both of these sodiums cancel? Can one of them cancel? What is the complete formula? Tell me the complete formula for this entity. Don't ignore the 2 right now. It just says there's 2 of them. What's the total formula here? Na aqueous plus, right? Do you see any Na plus aqueous on the other side? Yes. How many do you see on the other side? 2. So 2 of these and 2 of those. Is that okay? Okay, is there anything else that cancels here? The chloride and the chloride. Is there anything else that cancels here? No. Nothing else can cancel. So what is the net ionic equation here? Everything that didn't cancel out, yeah. Carbonate steals a hydrogen and turns into hydrogen carbonate. That's the net ionic equation. That's what's happening in this reaction. The carbonate is stealing a hydrogen and it's turning into hydrogen carbonate. That's what happened at the first equivalence point. Can you tell me, at the first equivalence point, remember, what is the definition? This is the fourth time I've asked you in the last 2 days. What is an equivalence point? Both of your reactants are completely consumed, right? They've totally reacted with each other. Do you have any reactants left over? No, you only have products. And you don't have any extra acid or extra base that you've been adding, right? Do you know what I mean? Okay, so you only have the products of the reaction. So tell me, do we have any of this stuff left over at equivalence? At the equivalence point, what is the definition of the equivalence point?
It's just the products.
Exactly. This and this have reacted. There's no more of them. What do we have at equivalence? HCO3, right? That's the only thing we have in our beaker. Okay? So at equivalence, we only have HCO3. When we start adding acid to HCO3, can HCO3 accept another hydrogen? Is it possible for this thing to accept another H+? Yeah. So that's exactly what we get. From here on out, it's only HCO3, and the HCO3 slowly starts to react with H+. And then at this point, the HCO3 and the H+ are all reacted, and we're done. We only have H2CO3 left. Does that kind of make sense? We only have H2CO3 here. H2CO3 is carbonic acid. It's a weak acid. Okay? I don't know. Hopefully that kind of makes sense. So this is just a little bit of a summary. Like we're totally done. We're done everything. We're just going to do a little bit of review and recap now, and then I'm going to get you to get another 5 minutes to work on your assignment if you want. So, do you remember when we're titrating a strong acid? Remember, a strong acid doesn't really have that hump. Do you know what I mean? Right? A weak acid will have that hump, right? Wim, your hand went up and down. Okay, all right, good. Your equivalence point for a strong acid and a strong base will always be what? 7, because you're always just making water and a neutral ionic salt, right? That's all you're doing. But the equivalence point with a weak acid and a strong base is going to be above 7. The equivalence point for the other one is going to be below 7, right? So it just depends on what happens, okay? So let's take a look at this. The first, examine the graphs below and determine which scenario they represent. Is it a strong acid titrating with a strong base or whatever, okay? So as well as tell me the indicator you would choose to indicate the endpoint of this reaction. What I want to ask you, what is the sample in here? Is it an acid or a base? It's an acid. And where is the equivalence point?
7.
So was it a strong acid that we started with or a weak acid that we started with? It's a strong acid. Okay, so the scenario is it's the titration of a strong acid with, I need you to understand, we always have the strong version of the opposite thing in the burette. Okay? So it's either a strong acid or a strong base in here. What are we adding? Are we adding an acid or are we adding a base to this? A base. It's always either a strong acid or a strong base. Always, always, always. So it's a titration of this sample with a strong base. Now, what's the indicator that you would use for this? Would bromothymol blue be okay? Yeah, there's a couple that we could choose, right? Would chlorophenol red be okay? No, because 7's outside. Would bromothymol blue be okay?
Yes.
Yep. Would phenol red be okay?
Yes.
Yep, it would be. It would be totally fine, right? Yep. So you could say bromothymol blue, or you could say, what the hell was the other one? Phenol red, so PR. Phenol red, whatever, man. It's all good. Take a look at the next graph. While I sneeze, okay? Figure out, are we titrating a weak acid, weak base, strong acid, or a strong base with something? I hate that.
You look like you're trying.
Yeah, when your face wants to sneeze, but your body won't let you, and it's just all of a sudden the pressure builds up. Like it feels like my brain's coming out of my skull right now. Which is a symptom of something called encephalitis. But I'm pretty sure I don't have encephalitis because I don't feel like I'm actually dying, so we'll be okay. So what do we have at the beginning? What's here? A base. What kind of base? What do you mean we don't know yet? I mean, yeah, at the beginning we don't know yet, but once you look at it, it's a weak base, right? Give me 2 reasons why it's a weak base.
pH of 6.
It's got an equivalence point that occurs at a pH of 6, right? That's got to be a weak base, right? So it's the titration of, we always say titration of sample with titrant. So what's our sample here? It's a weak base. Titration of a weak base with, what would we add to a weak base? A strong acid, right? And what would be the indicator of this equivalence point? What indicator would we use? Chlorophenol red? All right. Perfect. Tell me this. What are we starting with? It's the titration of what?
Strong base.
It's the titration of, what are we starting with?
Strong base.
A weak acid with a strong base. Does that make sense? What are we starting with? An acid. And we're adding a base because our pH is going up. And what would be the indicator you would use? That's a little high, I think. There we go. 8.5? I don't know. What'd you get for a pH? Is 8.5 okay? Okay. So what would you use, Roy? Thymol blue? I don't want to tell you no, but I love it, right? 8.5. Good. Awesome. What else could you have used? Maybe phenolphthalein, right? Phenolphthalein would have been fine. Thymol blue would have been okay. Phenolphthalein would have been fine. Okay, take a look at this one. This is the titration of a strong base with strong acid, right? 2 reasons. Give me 2 reasons why. Wim, 1. Give me 1 reason. The equivalence point is at a pH of 7, right? And what's the other reason? No, there's no hump, right? You don't see a hump. Now, I mean, really, it's the equivalence point that we care about. That's the biggest indicator. But if you see a hump, that's a really quick, oh yeah, strong acid, strong base, that kind of thing. Okay, what indicator would you use? Bromothymol blue. Perfect. What about this? What are we starting with? We're starting with a polyprotic acid, right? This is a titration of a polyprotic acid with what? Strong base. And what are the two indicators you would use? It's really super hard to tell because there's no information on the left-hand side. But just write down a couple indicators, pick them, and I'm sure they'll be fine. Any questions? Was that fairly straightforward? Yes. Okay. What? You like it? Yeah, that's interesting. I think it's interesting. And, yeah, and there's very little math involved. Would you agree? So it's nice. It's conceptual. It's just hopefully makes sense. Okay, I want to be very clear. We are going to try our best to start our new unit on Monday.
It's not acceptable.
Yeah, we'll mark it at the beginning of the class on Monday, and then we'll move on to bigger and better things.
Wait, what? Our unit exam?
Your unit exam is on Tuesday.
So
That means we
Monday's
mark our
a review day.
assignment on Monday.
We're just gonna forget it after the break.
When are you leaving?
No.
Tomorrow.
Did I tell you your job is to remind me every day for 3 days before you left? Yeah, you forgot. That's because I forgot.
That's how I do it.
Okay, I'm gonna go check. Don't leave yet. Even if the bell rings, don't leave yet. I'm gonna ask Newton if she told her class something.
I'm starting to read it Monday. Or the test is starting to read it.
Dude, tell me, like, I can't go to
I don't want to leave anyway.
Yeah, we're gonna mark it at the very beginning of class on Monday, and then we're gonna burn through some information.